Have you ever wondered how the simple act of dropping an apple led to a scientific breakthrough? An apple falls from a tree and boom, the universal law of gravitation is born. It sounds like a fairy tale, but this is a real story from the life of Sir Isaac Newton. Imagine a universe where the force of attraction between objects didn't exist. Planets wouldn't orbit the sun, and we would simply float off into space. This invisible force that keeps everything in order is gravity, governed by the universal law of gravitation. Crafted by Sir Isaac Newton in the 17th century, this law explains the attractive force between any two objects possessing mass. Newton's law, in its simplest form, states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Breaking it down, we have the formula F equals G times m1 times m2 divided by r squared. Here, F represents the gravitational force between two objects, while m1 and m2 are the masses of the objects. R is the distance between these objects. G is the gravitational constant, a number that puts everything into perspective, making the formula work in our universe. This law isn't just a fancy equation for scientists to play around with. It's a fundamental rule that influences our daily lives. The weight you see when you step on a scale, that's gravity at work. It's the force of gravity acting on your mass. And how about the design of spacecraft trajectories? Well, the universal law of gravitation comes into play here too. Engineers use it to calculate the amount of fuel needed to send a spacecraft to a specific destination. Even the predictable rise and fall of the tides is due to the gravitational pull of the moon and the sun. Scientists, using the universal law of gravitation, can forecast the height of the tides at any given moment. To summarize, the universal law of gravitation is a cornerstone of physics. It explains the force of attraction between objects, is used to calculate weight, helps in designing spacecraft trajectories, and even predicts tides. It's a testament to the genius of Sir Isaac Newton, a simple law born from an apple falling from a tree that continues to unlock the mysteries of the universe.